This time we are in beautiful San Mateo. Hi,
Hi.
Emil. Who are you and what do you do?
Guten Morgen.
Good morning.
Yeah, that's it. That's all the German I know, as you know. So my name is Emil Eifrem, and I run a company called Neo4j, and we're a graph database company.
Cool, what's that?
So a graph database is a database model that is inspired by the human brain. Right? So the human brain is structured in neurons with synapses connecting to other neurons, which builds up a big network. Right? And the mathematical word for network is a graph. And so what we've built is a database that, rather than using tables, which is sort of the standard model, or it used to be the standard model, it uses nodes and then relationships between these nodes, which then builds up this big graph. And people know the word graph now because of Mark Zuckerberg, right? Social graph. And that's definitely a very common use case, right? You know, the nodes are people and the relationships are whether you know each other, right? But we have a lot of other use cases. In fact, social is not even the most popular use case for us. So, for example, fraud detection ends up, with every node is a transaction, right, or an individual, and then you have relationships connecting all of these, and you want to find patterns in a big graph of payments. So that's one use case. Identity and access management, right? So you're a big corporation and you're a big financial institution, right? So we have a lot of big financial institutions, and you want to onboard a new trader, and that trader has access to a subset of all of the collateral that the bank has produced, right? And the specific subset is controlled by whether what nationality they are actually, what projects they worked on, even what colleagues they've worked with before, because sometimes you may have insider trading rules if two colleagues who have worked before have access to the same thing, right? So that's a very big, connected, complicated mass. And another final example is recommendation engines, right? So people bought this, also bought that, those kind of things. It's also very graphy in nature. So those are some examples of use cases. You get, if you have connected data, you sometimes get 10 times faster performance than a relational database, an existing table-based database. But sometimes you even get 1,000 times faster or 1,000,000 times faster. So it's dramatically faster when it comes to these kind of type of connected data operations.
Emma, you are from Sweden. How did you come up with this idea and how did you start?
So we actually ran into the problem ourselves. So we worked at a startup in Sweden. It's three founders of the project, at least, three founders. And we worked at this enterprise content management company, which is basically... Can I draw? Will that stick on camera if I draw?
Yeah, I guess so.
Yeah. So basically the problem that we were building an enterprise content management system, right? And enterprise content management is basically like web content management, which is the popular one that everyone knows today. So it's basically a big file system on the web, right? Where you have folders like this, where you have other folders in those. And inside of those folders, you have files like this, right? This, of course, is a big tree, right? But it turns out that when you add security to this, so you're able to say that here's Martin over here, he belongs to this group, maybe product marketing, let's say you're in product marketing, this product marketing group belongs to the marketing group. Marketing has read access to this folder, but product marketing has write access to this one. So all of a sudden when Martin logs on and we need to check whether he has access to all these things, you're gonna have to look at all of this big connected mess over here, and this big connected mess over there, and the connections between them, right? And so we had this problem, and we tried to store that in normal square static tables, which is entirely possible, entirely doable, but it's just really, really fucking hard. and so what ends up happening is that you end up doing a lot of joins, you end up doing a lot of convoluted things, and when we started, we were 10 people in the company, 5 people in the engineering team. And I was like 20 years old, right? But a year later, it was like 50, 60 people and 20-person engineering team. And I was the CTO. And I noticed that half my team basically spent the mass majority of their time just fighting with the relational database. And at that point, we said, what's going on here? Like in all my other projects, the relational database has been my friend. so what's going wrong here? And then we realized that after we double-clicked on that and really tried to figure out what was going wrong, it was this mismatch with the shape of the data that we had and the tabular abstractions that were exposed. So at this point we said, there's got to be a better way. What if there was a database that just had this graph structure, worked exactly like the relational database, but had a graph structure instead of tables? That'd be amazing. That would solve all our problems, right? So we said there's got to be someone else must have had this problem. So we we didn't Google around. We AltaVista'd around and Lycus'd around and Excited or whatever. I mean, the search engines at the time, right? But basically didn't find anything. And at that point we said, the famous words, right? We said, hey, let's just build it ourselves. How hard can it be? It turns out 15 years, this was back in 2000, 15 years later, it is pretty hard to build a database. So basically, that's when we decided to build this thing. And we built it for a couple of years. It was only an internal tool, put it in production in 2003. So it was then backing that enterprise content management system. We always thought of it as something that is very generic. We did not optimize for this particular use case or anything like that. And we really initially had, already from the start, we had very high aspirations and felt that this was something that we wanted to unleash upon the world. Because it just seemed unlikely that we would be the only people with this problem. And also, just at a macro perspective, if you take a step back, are we moving, to a more disconnected world or a more connected world? That's kind of it's a naive question how obvious it is, right? Mm-hmm. Well, but if that's true, that's going to make consequences in all parts of the stack, right? And ultimately, everything we do with technology ends up in a freaking database. Right. Everything we do, like this thing, like every software that we touch, these mobile phone, everything that we touch multiple times per hour, all of that ultimately leads to a consequence in some database somewhere, right? And if the world is becoming increasingly connected and there's value in representing those connections, then that's going to exert a lot of pressure on the existing infrastructure. And we just didn't see that over time we would become less relevant. On the contrary, we felt like we were sort of on the right side of history. But in the early 2000s, there was absolutely zero market acceptance for taking a new type of database to the market. So I don't know how old you are or if you were around back then, but basically in the mid 90s, there was this surge of object-oriented programming languages, right? And on the tail end of that, there was also a surge of object-oriented databases. And the narrative was that, we have round objects now, we can't put them in square tables, right? Instead, as the world is going to move to an object-oriented paradigm for their programming languages, we are going to also store those objects in object databases. It makes sense, except it didn't work at all. And there are a number of reasons why, and the key contributing factor was one keynote by Larry Ellison at Oracle Open World, where he basically wiped out an entire industry with one keynote, Larry Ellison style. But so the industry kind of tried out this whole object-oriented database thing, failed miserably, and so the discourse in the early 2000s was something like the relational database will always be the only database model. It's now proven itself. It's like people thought of it as a mathematical sort of axiom that we can build stuff on top of the relational database, but it will always be there as this fundamental thing, right? And that was the discourse in the industry in the early 2000s. And we said, look, we have this amazing graph database, and it gives us all kinds of benefits. And again, we thought that we were on the sort of right side of history, like macro trends should be in our favor. But we just said, there's no acceptance in the market to take this, out there. And that changed in 06 and 07. So what happened in 06 and 07 was that Amazon published a research paper, an academic paper, called DynamoDB, where they said, we're Amazon, we tried a bunch of different things, but we were unable to solve our problems without having to invent our own database. Right? And if your goal is to be an e-commerce site or sell books or sell compute resources, whatever it is that Amazon wants to do, you don't want to build your own database. You want to use some other database off the shelf so you can invest your energy elsewhere, right? But the very, very, very smart people at Amazon had concluded that there was nothing off the shelf that worked for them. And then they wrote a paper outlining how they did that. And then a little bit later, Google announced basically the same thing. They wrote an academic paper called Big Table, where they said, hey, we're Google, we have some amount of expertise on managing data, and we've also tried with the relational database, and it's also failed for us. So we've also had to invent our own new type of database, and we call it Big Table. And so this caused a lot of stir in the development community. And all of a sudden, people started realizing that, well, actually, maybe the relational database isn't the only thing that's going to be out there. And then, of course, for a while, like as with everything, there's a pendulum, right? And so people then started thinking that the relational database is going to die and go completely away, which of course is never true. And now I think we're sort of in a little bit of a fairly informed state where people, I think, generally acknowledge the fact that the era of the one-size-fits-all database is over. We're no longer just going to take all our data and shove it into a single system. In the past, that's of course been the relational database. But on the flip side, what we're going to do as data architects is we're going to look at our big data set, because all data sets will be big, and we're going to look at, hey, this part over here in my data is tabular in shape. So let's put that in a relational database. This part over here is what I call tall, skinny tables. So just key value pairs like this. Let's put that in a key value store. And this part over here is big and messy and connected and chaotic and dynamic. Awesome. Let's put that in a graph database. And so we saw that and spun out the company in 2007. Took all the IP on the database side and moved that into this new company. Bootstrapped for a couple of years and then raised a small seed round in 2009. Focused on community and product. We're open source. And then in 2011, we raised our A round, moved over here, and started focusing on building an organization, actually commercial customers. And that's what we've been doing since.
Cool. Let's talk about the technology. So imagine I'm a company and I believe in the big data paradigm. I've built all my data pipeline, and then I would, for a specific use case only, for example, use Neo4j, right? And I would only take a subset of the data which I think applies to the use case, right?
Yep.
Awesome. Is your database like scalable over the nodes?
Yeah. So it scales out horizontally, right? So we don't use the word nodes because nodes means something else for us. That's in the graph they're called nodes, right?
Yeah,
sure. The data elements, right?
The old nodes.
It's a little bit of a terminology confusion, but but it scales out across machines.
Okay, good.
Right? So you can scale horizontally on commodity hardware. It runs on top of the JVM, so it really can run wherever the JVM runs, which is most places. It also scales up very well, right? So one of the interesting aspects about a graph database is that you typically don't want to split up the graph across multiple machines. You can, but it's really hard, and it kind of sometimes leads to problems where if you're going to, in order to satisfy one query, you're going to need to hop across the network. That's typically not very fast. So it's awesome if you can fit the entire graph into one machine, right? You don't have to, but if you can, that's good, right? And so we've worked also, in addition to working a lot on scale out, we worked a lot on scale up. So that makes sure that if there's a lot of memory in a machine, that we honor that really well and use that really efficiently. And
the Neo4j is only the graph database, or are you also offering tools for pattern analysis, data visualization, etc.?
We do a little bit of the tooling. I'd say 95% of our bandwidth goes into building the core database engine, right? Just because we're a small team and it's quite a big effort building a database. But there's some amount of tooling offered by us and a lot of tooling offered by the ecosystem, right? So today we are the most popular graph database by a wide margin. Actually, if you look at sort of objective measures, we're probably twice as big as all the other graph databases combined. And not necessarily because we're so much smarter, so much better than anyone else, but we just got started earlier. And that does lead to a number of really interesting benefits, in particular around ecosystem, right? So since we have the largest user base of graph database users.
Yeah.
It just makes more sense for any tooling provider to write to our ecosystem. So that's a nice benefit of being sort of the leader in a category. And so we rely a lot on external tooling providers to provide the stuff around the database.
Cool. And what things are you doing in order to foster this kind of ecosystem?
A couple of things, right? So first off, we're open source, and I think that's really the key thing, right? And we have a community edition, which is available, for free. You can use it wherever you use MySQL for free. You can use Neo4j Community for free.
Yeah.
It's the same license, GPL. So that's the key one. Then we of course do a lot of things to sort of try to grow the community and engage the community. Last year we ran, this is kind of crazy, we ran 500 Neo4j events.
Wow.
Last year. 500.
Yeah.
And this is in
only US or
worldwide.
Wow.
Worldwide. So if you go online on neo4j.com/events today, when you watch this, you're going to see 2-3 events somewhere probably.
Wow.
And there's a lot, and I kind of lied there because I said we run them, and that's not strictly true, because the vast majority of those is just volunteers. People who love the technology so much, who're so fascinated by it, that they start a meetup group in Kuala Lumpur or in Osaka or whatever, right? Wherever, right? And they just talk about use cases, they talk about customers, they talk about new features, etc. And so our role in those is typically, we write a check for the pizza or something like this. But we also have, big events. So next week we have Graph Connect, which is our annual big conference that we run twice per year. That's how annual it is. In the fall we run it here in San Francisco, and then springtime we're in London. And we're expecting about 1,000 people.
Wow.
Next Wednesday and Thursday here in San Francisco. So it really ranges from the 10, 15, 20 people spontaneously, informally organized pizza and beer, all the way up to a big professional event. But those are some of the things that we're doing to sort of foster and grow and engage the community.
Cool. Emil, you said that you are open source basically.
Yeah.
How do you make money?
So we're open source, but we also have, I mentioned the community edition, which is available for free off of the website, etc. We also have an enterprise edition, which has a number of features that if you're a big company, you don't need them, but you really want them, right? So, it things like the clustering that we discussed before, which if you're Walmart, who's a customer of ours, right, or UBS, who's a customer of ours, and you have a graph database running in production, you don't want that running on just a single machine. You want that replicated and clustered across a number of machines, so that if one goes down, the cluster will still be up and running, right? So there's a large financial institution which use us for onboarding of traders, the use case that I mentioned earlier. And if we're down a minute, like the entire bank stands still, right? So it handles 50 million requests per day, right? If that's down for a minute, that's millions and millions of dollars, right? So that just cannot happen. So obviously, then you want clustering, and that's available in the enterprise edition. So that's how we make money, and then we sell it in the sort of normal fashion these days, which is a subscription-based model. So you pay every year for your right to use the software, and so that's how I'm able to buy water at Starbucks, and so on.
And how do you acquire those customers? Is it mainly due to the community aspect, or is it that you are having a direct sales force, or maybe even a partner network?
Yeah, that's a great question. So the actual acquisition is, I'd say, 90 plus, and probably 95+% is organic inbound through the community work that we're doing. So it's someone out there who picks up the software, plays around with it, typically during weekends and evenings, likes it, realizes that, hey, I actually had a problem like last year that this could have solved, and then the following year they run into the similar problems, like, oh, maybe I'll try out this graph database thing, right? And then they try it out, start playing around with it, realize it does solve their problem. At that point, if they work at a big company, typically they call us, right? And the moment they call us, we have a direct sales force. We're very much a traditional enterprise software company. you know, in the sense that we have actual people answering the phones. But we, you know, do vast majority via phone. So it's not go out and visit with customers. That's the primary one. But we do $1 million deals. Actually, you know, recurring revenue $1 million deals with global 2,000 companies, working with the CIOs, and it's a very big strategic bet for them.
Mm-hmm.
And at that point, of course, we go out there and we shake hands, right? So that's how that model works.
In the beginning of the interview, you said, how hard can it be to develop a database? Yeah. If you look back, why was it so hard?
Wow, that's a great question. So I think there are two aspects to that question, right? Well, sure, there are multiple nuances, but I'm going to focus on two aspects, right? First off, it is technically very difficult to do a database, right? And we have very high aspirations. There's a number of these sort of NoSQL databases out there that, for example, they said that the relational database is good with some things, but they threw away a lot of the things. Mm-hmm. And one of the things that they threw away that we disagree with is transactions, mm-hmm. right? So transactions means that if you run a number of operations and if you write to the database and then you say commit, then once the database says back, yep, that's committed, the database will guarantee that your data will be there forever, right? And we think for a database, that's not a negotiable feature. that has to be there. And actually a lot of people, strangely enough from our perspective, disagree with that. Mm-hmm. And it's very, very popular today to talk about eventual consistency and things like that. And we actually really agree with eventual consistency, but we want to do that layered on top of a transactional core. Mm-hmm. My point is that writing this software is really, really hard. Really, really hard. And it's the kind of thing where it's like 9 women won't give birth to a baby in 1 month, mm-hmm. right? It requires calendar time, right? So it requires you to be out in the wild with customers in production for a long time in order to really get the kinks out of that system. Just as an example, right? So early on, you know, we had situations, this is like back in whatever, 03 and 04, right? So a long time ago, where, you know, if someone was writing a transaction to the database and the database crashed. Mm-hmm. So one of the things that we do, unlike some other databases today, is that we will always roll back to safe state. So you will either not see that transaction at all, or you will see the full transaction. You will never see half written data, right? And that's, in order to do that, you basically use what's called a transaction log. And without geeking out too much on this, although I'd love to do that. Suffice to say, it's basically what's called a transaction log where you write your data to. Yeah. Now, so what ends up happening, or happened to us in 03 and 04, was that if the database crashed while you wrote this data, that was fine. When you booted it up, after the machine booted up, mm-hmm. when you started the database, it would just recover, mm-hmm. right? Bring it back to a stable state. Except there's a little bit of a process, it's called a recovery process, where it reads the logs, it tries to figure out what is that stable state. And what happens if you crash during that time? Mm-hmm. Well, then you need to be able to recover from that.
Infinitive loop, yeah.
Exactly. And those are just one tiny little example of the kind of sort of loopholes that once you're up and running with tens of thousands of customers mm-hmm. in production, you're going to run into all of these kind of eventualities, and it's going to be on the combinatorial explosion of different versions of the Java virtual machines combined with different versions of the 10, 20, 30 different OSs out there, on the different versions of disk controllers, and that's a very large combination of things that you need to guarantee that it works, right? Because that's ultimately what we sell to our customers. It's peace of mind, trustability with their data, right? And so it must never fail. And writing that kind of software, it just takes a lot of time. So that's one aspect. And the second aspect I actually alluded to before, which is that there was just no market acceptance for a new type of database. Mm-hmm. And what we've done is one of the hardest things in technology, in that we've created a new category. Mm-hmm. This is equivalent what, for example, VMware did back in the late 90s, right? No one knew what virtualization was. It actually had been invented earlier in the mainframe era, mm-hmm. but basically they took the concept and created a market around virtualization, right? And Palm Pilot did that when they launched, if you remember Palm Pilot, right? Okay, yeah, that dates you actually. But I mean, so they launched this thing that was this personal digital assistant, PDA, mm-hmm. right? It was phones then ended up killing them, right? But they created this new category, right? And we've been able to do that with graph databases. Graph database is a term that we put together with some academic articles from the 80s, but that looked nothing like the modern graph database. And so we just took the word graph and database and put it together and started defining it and giving it meaning and popularizing it. And now it's, Forrester Research, which is one of the big analyst firms, says that 25% of the enterprise will be running on graph databases in 2017. Right? Gartner says that 75 to 80% of leading organizations are going to be piloting a proof of concept in graph databases by 2018. Right? The entire Global 2000, the entire Fortune 500 will be using graph databases in production by the end of this decade. And going from, that's a very much a 0 to 1 kind of thing in Peter Thiel's terminology, right? So going from absolutely zero, putting those two words together into, where we're heading, we're not nowhere near done yet, right? But where we're heading is very, very hard and takes a lot of work.
When I look at entrepreneurs, I always think, okay, one thing, they need a vision and they need to be naive. Yeah, and this is a good example.
Yeah, that is because
if you would have expected how hard it would be, we would never have started.
For sure, that is very, very true. And if someone had told me back in 2000 that 15 years later you're still going to be working on a piece of software, I'm like, dude, that's never going to happen.
6 months maximum.
Yeah, exactly. Yeah. No, I mean that's very true. If we had known how difficult it is to pull off, right, and all the things that could have killed us and should have killed us, we never would have even started.
Cool. Emil, what startup advice could you give first-time entrepreneurs so they make less errors that they could have avoided?
So first off, I think startup advice is really hard and really dangerous because, I think so much is contextualized. And I actually think that some of the most brilliant things in life, but let's focus on building companies. Some of the most brilliant things in building companies comes from people who go completely 180 degrees from common wisdom. Right. And so I actually try to refrain from giving generic startup advice. Having said that, I think the things that have helped me is the obvious thing, which everyone does say, right? Which is passion for what you do, right? Because I've been doing this for 15 years. Sure, the company for whatever, 7-8 years, but worked on the technology for 15 years. And every freaking year, I've had more fun than the previous year, right? When we were 2 guys and hadn't had salary for a year, right? And were just so completely dirt poor, I still had so much fun, right? And then when we grew the team to like 6 people, it's like, oh, wow, we actually have a team now. That's amazing, right? And then we became 15 and 20, and it's like, we kind of need some kind of like management or something here, right? All the way up to now, I guess we're 110, 120 people, right? And we're across 12, 14 countries on as many time zones probably. I'm still having as much fun as I've ever had in my entire life. So I think that has to be there just because it's so hard that if you're not crazily passionate about what you do, you just won't have the persistence to do it. So I think that would be the first and obvious one. And then there's the tactics. Stay close to your customers. If you aren't the customer yourself, and some of the best technology I think in the world is being written for the people who are themselves the customer, then really have empathy for the customer and stay close to the customer. Both are truisms, both are things that everyone is saying. They have helped me a lot.
Emil, thank you so much for your time.
Pleasure.
And
Dankeschön.
Gern geschehen. And next time you're thinking about starting a company, you have to be passionate, but you need to think about ideas that are contrary to what the mainstream is thinking about, but you have to be right. And then you are starting a successful company.
Contrarian and right.
Right. But contrarian and false is not a good choice. Yeah? Okay. Thank you so much. Great.
Awesome. Pleasure.